Here's the attempt at a demo.
We're going to switch over to some backups here. I have a feeling we might have the same problem.
They say never do a demo, but I'm going to try it. Hey Sally, tell me how production is today. Oh, obviously it's not working. Give me a second.
There we go. Yes, I know that. Well, geez, I don't like this. All right, let's go back to the primaries. I'm afraid I have a problem, and I'm not going to be able to show you much here today.
No, I don't want to do that. But I think the message here is it can happen. It's this idea of large language models, which is the newer stuff, the sexy things that everyone is kind of talking about. So to paint the vision that we have for Jendamark, because we've got these digital infrastructure or digital solutions that are embedded inside the production line, we've got access to a lot of rich data. And I think one of the biggest challenges that we've experienced in factories is the anxiety that production people experience in not knowing what's coming next, what problem is coming next. Most production people, whether it be maintenance, quality, production management, whoever that is, if I tell them what the problem is, they dive into it and they can solve the problem. What really causes the issue for them is they feel, and when they put their head down on the pillow at night, they wonder and worry about what might happen, because they just don't trust that the systems are running correctly. And so I think there's a big opportunity to create these agents and assistants for these different personas inside a factory. So we've come up with 3 agents, Tom, Dick, and Sally, and I deliberately give them human names because they become assistants. And we need to interact with them like they are our assistants. Like I could ask Nick, please tell me how's the production going? And if you're in production, if you have that information, you should be able to respond to me in a human-like way. Whereas the way we interact with data today is very engineering-like, very transactional. Whereas I think that the advancements of large language models allows us to do something a little bit more human. So here's the attempt at a demo. They say never do a demo, but I'm going to try it. So I've tried to do something here. So I'm going to ask a question. Hey Sally, tell me how production is today. So it's going to go through this data set that I've put in here is 500,000 lines of data, just to give you some context. So it's writing some code. I'm using Gemini for those of you that don't know or were interested. So it's now thinking. Okay, so let's see if I can get it to talk to me. What's going on? Oh, obviously it's not working. Give me a second. No, I don't want to do that. But I think the message here is it can happen, right? I think this is a.
You're very brave to actually take it on the fly, actually.
Yeah. It was a 50-50 this morning.
Oh, okay.
Yeah. So I've just asked it again. Pardon? Yeah. No, it responded, but I wanted it to speak back to you, not just give you the text.
Hello, Sally here. Our focus is hitting our 96-second time today. Here's the status. Throughput status. We are at 534 unique parts completed for the day, putting us at 98.9% of our 540 part target. We are extremely close to hitting the goal, so let's push hard for the finish line. Primary bottleneck. We have a long list of operations with an average cycle time over the 48-second target. The worst offenders are STN310L, shafter C-scan, and STN310R, shafter C-scan. These processes are running too slow and creating a chronic drag on the line, instability warning. STN310L, positional retainer bolting 3, is showing the highest count of erratic performance anomalies. This station is showing the most unstable performance and could crash the line soon. Action. Investigate flow material presentation here before this ghost bottleneck becomes a hard stoppage.
So that was me asking Sally. Let me ask Tom. Hold on. Tom, how are we looking from a quality perspective today? It's thinking. 500,000 lines of Excel.
Hello, Tom here. I've run the quality scan. We have a critical process alert right now. Failure point, STN 110. Runout gauging, station 110. The data. The rolling CPK is at 0.694. This means the process is failing the basic 0.8 threshold diagnosis and action. The process is showing poor capability. The mean is drifting toward the specification limit. Immediate action. Inspect tooling wear and adjust the mean target value to center the process.
So that's Tom, who's the quality agent. And just by the way, I never told it about CPK. It's just got a whole bunch of Excel data that is the results of a particular production line, or 1 week's worth of data. And then let's just ask something about people. Hey Dick, can you tell me which operators are doing the best? Give it a sec. I'm not normally nervous standing in front of people, but it's testing me today.
Dick here. Let's talk about the team, top performer. O Operator 2 is currently leading the line in throughput over the last 24 hours, a great example for others, coaching opportunity. O Operator 54's performance on STN 310. Positional retainer bolting 4 is trending slower than their own average. Action. This isn't a reprimand, it's a signal for the line leader to provide proactive, targeted guidance or check their workstation's ergonomics before a quality issue, Tom, or slowdown, Sally, occurs.
So thank you. Well, you can thank Gemini. What I did was I anonymized the operators' names because I wasn't sure if I'd get in trouble.